I've been collecting a lot of different items on my workbench with the intent to tear them down at some point and just see how they work. And it's gotten to the point where I've run out of desk space. So, time to actually go through some of these things. This has been one that's been here for a while. So, when I bought my house, there's a reason. The house was built in the 80s, and this was a irrigation controller that was attached. And it just looked interesting. It's such an old design. It actually looks like it has one of the LED bubble displays. You know, I haven't even tried turning it on. Let's just see what happens. I'm curious. Runs on 24 volts AC, and so this is just a transformer. Yes, I'm going to plug it into a isolation transformer to see what happens. Oh yeah, it does work. Yeah, cool. That's a really neat display. I might actually want to keep that. I don't even see it. Yeah, there you go. So anyway, given the sheer age of it, I was just kind of curious as to how it works internally. So let's spend a little time pulling things apart. If you hear a lot of noises, that's my puppy just came to join us. Somebody else is notified. Ask questions. All right. So I have a new irrigation system, so I really don't need this for any reason. So if nothing else, the intent is to simply take this thing apart and harvest any pieces that are interesting. Oh my gosh. Yeah, I have a really terrible selection of tools here. Goodness. So it is interesting. It had a 24 volt input, but it also has a 9 volt backup battery. Kind of strange in my mind. What is this? Yeah, this says the instructions here have a revision C from May of 1988. So, you know. I don't know how to get that from that. Oh well. Just hold that all over the place. And as is usual, power adapters are usually useful. In this case, we have these pins. They're just trash. Literally, they're two folded over, or it's, you know, the metal just got folded over to make it thicker. So This is all that old plastic. It yellows really easily. As every child of the 80s got familiar with. Opening that. Alright, let's see what's in this thing. Now keep in mind, this is an irrigation controller, so a sprinkler controller. This thing should have been made as cheaply as possible, but think about what it's doing here. You know, you've got slider switches and you have zone control for different programs, so each zone has how long you want to go, which days A and B to run. It's actually pretty sophisticated for the design that it is. Clearly designed not to be serviceable. It's like all of these are heat staked in. Let's put the front plastic on it. Look at all the flux on the terminals. You know, they probably would have had this machine assembled. You can see like they hooked the leads on the IC there, so they're hooked over so it would stay while they ran it through like a wave solder or something. But when they got to this last terminal barrier strip, they had to hand solder it, and they just left all the flux there. Alright. Ooh. Okay. So the way those slider switches seem to have worked is actually that inside the plastic here, inside the front, they just had you can see a little wave pattern there for the notches for it to create the little detents. And then these little metal pieces were spring contacts, both to keep the tension on the actual slider as well as to create the short across these two trace segments. So you have a single long trace that's the feed, and then you have all the individual jumps out, and then they, you know, jump onto the back. And it looks like they did something, some sort of row column scanning actually, because if I look at a lot of these rows, you know, there's the one row here, and that runs off on the top. But then they also have the row running across on and tapping off all of the traces going across. So let's look at what we got around the edges. So an LM339. A 74-137, 4051s and a COP 421. So clearly everything that would have been on this, programming-wise, would have been on that COP 421. That's old enough, I'm not familiar with it. And it looks like they used what are they doing here? Yeah, so the 74137 looks to be used. The outputs are coming through a resistor and running into a transistor on the other side. So they have a whole series of 2N6071s that are the actual output. And irrigation systems are often 24 volt solenoids. So that makes some sense of they actually needed to drive all those different outputs. So you had your power inputs and then you had all the different zones that you were going to go. And usually what you would do is bring, for the zone wiring, you'd bring one end to the individual zone, then you have a common that ties in, probably on this last one. Is the ground. The 9 volt input here. Kind of hard to figure out what they did. I mean the 9 volt pin here. Yeah, they tie into a negative, but that looks like a half-wave rectifier actually, because there's the positive lead coming in and it runs up to a cap through a diode and another diode and a diode resistor to ground, back to the other side. What are we doing there? Yeah, those are shorted on both sides. Yeah. It's almost like there's two different half-wave rectifiers happening. How would that work? Yeah. This input here, the input power comes around on the back and comes up to here, to this diode, and they have a resistor down, and then but it also comes straight up on the front side and goes through this diode with a resistor down. So they actually generate two different rails there. And those are 1N932s. Alright. Seems right. So, yeah, pretty simple design. Took up with this. Not really sure about the COP 421. 137. Let's just do that. So. Yeah, so they're using the 74137, which, I always have a hard time remembering what all those parts are. So it's a 3 to 8 decoder, and so if we look, there's likely to be a set of lines 1, 2, 3 that run up here all the way back up to the COP 421. So the COP 421 is a really old national semiconductor microcontroller platform. I knew that name sounded familiar. It actually, when I was talking with some of the folks that build Nuvoton microcontroller, their baseboard management controllers, their BMCs, and also their TPM portfolios, their Israel office actually originally was an office set up by National Semiconductor, and so they still use a COP 421 core, or the COP 400 cores, as a microcontroller architecture for onboard devices. So like when they need a DMA engine or they need a little RISC coprocessor, that's the core they drop in. So anyway, so yeah, that explains the 8 zones that you would use, and then 4051s are they're just doing counting, and so am I misunderstanding what they're doing? So, yeah, I misunderstood. 4051 is a 8-way mux. So they are, how are they going to work? So they're using a 3-bit decoder here to select one of the zones. But there's only 6 zones. So they use this, which directly triggers one of these outputs. They're not using all of the outputs, so they're really using that to just select the 6 output zones. And then here, it's a similar, here you're doing an output, and this is really, a similar idea. They're using 3 bits for the select, to select from one of 8. And you can see that bus kind of running down from the processor. And on the back, they have the row. Most of the rows actually come back. Huh, that's interesting. Ties into the display logic. Here's, they just have some jumpers underneath the display, actually. There. But what are you doing? I think they chained them. Is that what happened? Yeah, it might be that they chained up outputs there. Anyway, they're using this to select one of the rows, and when they select that row, it's going to tie into the grid or the column. So they're using this as a way to demux. Yeah, they're using some of these as row and some of them as column. And so yeah, they're just using it as a way to actually to strobe out the different different outputs there. Huh. And the 339 is they're being used to do some sort of voltage regulation. Because what I also noticed is like they're actually, the 9-volt here is being tied directly into a power rail, which is entertaining. You know, that's how they keep the time powered. Because they're actually using some sections of these muxes to actually deal with timekeeping too. So it's like they oh, I'm just not seeing the traces right. Yeah. So these are the column selects on the 4051, and then the rows, when they get shorted, come back and actually run over here to the button inputs, which are also routed straight into the 4051. So they can strobe out each of these columns across all the different chips and then they they can strobe out this row of buttons at the top, and then they can strobe out each row across all these. Yeah, that's what they're doing. They're strobing those out and then feeding that into the processor to do its thing. Looks like they might even be mapping a couple of the rows across. Basically, it's a gigantic matrix, so it's all button pressing there. And so the display output is just a couple of taps here, straight off the micro. That's 7905, so a negative voltage rail. -5. It's actually a really interesting design. I mean, fairly minimalistic, but it really is a microcontroller with some peripheral breakout to do a keyboard multi-muxing, and to build a little regulator and some driver transistors. But I'll harvest some parts off of it. I might play with that COP 421. It looks like I can get a datasheet for it, and I've heard that you can actually get a GCC version for it. So might be entertaining to play with. So, what else is on my bench that's interesting? Destroy pile. This is one that a little different. So if you follow me in a couple different forums, you know that I've been working on a race car, so a drag race car. Now, one of the things, there's a couple of things that are unique in drag race cars. Where this comes in is that if you have ever watched a drag race, the goal is to drive in a straight line, quarter mile, go as fast as you can. And part of that is actually being able to get off the starting line as fast as you can, which can be really tricky because you have so much torque in these engines that you can actually spin the tires pretty easily. Now, the other extreme is that they usually have turbochargers or superchargers on them, which mean you need some amount of engine speed before you get full power. So if you actually are at the line and you're idling and you punch the gas, you're not actually going to get as much torque as you would hope because it actually needs to be somewhat spooled up, especially for turbochargers. That's a big deal. So one way you do that, one way you actually generate the Jeez, ow. Yeah, so one way you actually deal with that problem is you rev the engine at the line and hold it at a particular RPM so that you have enough, the supercharger or turbocharger is spun up and giving you a boost as soon as you come off the line, which gives you as much power as you can get. But you're actually going to get more boost if you are not only just spinning up the engine like you were holding it at an RPM while idling, but also if you have the engine under load. So it's actually trying to do something. And usually these cars are in automatic transmissions, but like a 2-speed. So they'll have a power glide in the higher class, or like the car I have as a Power Glide. So it's a 2-speed transmission, automatic sort of, like essentially it's a linear, what would you call it? Linear sequential. So you have a high and a low gear, and you can switch directly between them, and it acts like an automatic. In that sense, you don't have to control the clutch, you just bump from one gear to the other. But when you're at the starting line, what you want to do is be in low gear, and you want to be able to launch as fast as possible. So you don't want to have to do a gear shift, you don't want to have to push on, you know, you want to have the engine trying to make the car go, and then let it go. So in a transmission for a drag race car, often people will talk about having a transbrake or a transaxle brake. And so the idea is that you do have brakes on all 4 wheels. You need them in order to stop. But you're actually more interested in, at the line, you want the brakes to be holding the car where it is, but you also want the engine to rev up, applying a lot of torque to the transmission. Like, you actually want to be trying to turn the transmission as much as you can. And you also want the transmission to not be moving the car forward, but in gear. So what they do is they modify the transmission so that the reverse gear has a separate actuator to enable it. Because in an automatic transmission, you can engage multiple, like, in theory you can engage multiple gears simultaneously. Like, essentially you control which bands are engaged, or, you know, it depends on your transmission design. But in this case, with the Power Glide transmission in our car, it does have a Transbrake assembly, which means if I put it in reverse gear on the gear selector, it won't actually be in gear. I have to push a button to actually engage the reverse gear, in addition to being in reverse. And when I'm in forward motion, or in one of the forward gears, I can also push that button down to engage reverse gear. So I can actually be both in forward and reverse gear simultaneously, so that when I rev the engine up, it's actually trying to push both ways, which lets me load down the engine, build up a lot of boost, and all I have to do is let go of that button in order for all of the power to suddenly be forward only. So you get a very, very, very aggressive fast launch. So the way that works is that button is controlling a solenoid, and that's what this is. It failed in the car. It became a short, and so I bought a new one, and I thought, why not? Let's keep the old one and see what's inside of it. So, this screws into the valve body, or the valve assembly of the transmission, and here we've got a pin with some seals on it that actually, this plugs in, and inside that valve body actually there's liquid, there's transmission fluid, and it's pushing a pin inside of there to engage reverse gear. So this pin would be the piece that's popping forward, and would be the actual actuator for the servo, or for the solenoid. What else is in here? I was actually really annoyed. These things are really expensive to get. I think this is $150 or so. And there's a whole lore around these things, as there is with most stuff in racing, about what is acceptable use of these. So in this case, it's a discussion about, well, you should only use your Transbrake for brief periods of time. They're not meant to be used for a long period, so you'll actually burn out the solenoid if you hold it down too long. And that just bothers me. Like, why would you build a solenoid that gives you the fast response you want in terms of electrical power, you know, in terms of motion, but doesn't actually hold up when you heat it. So it really doesn't seem to have that many parts. It's essentially these two pieces like this. Inside of a bobbin, there's nothing else really in here. It's just an end cap. They're supposed to be for some heavy duty, or, you know, for, what do I want to say? They put them in a case like this so that they can be exposed to dirt and grime. You can get them in an open style that doesn't need that. But, I mean, clearly I've gotten transmission fluid inside of this one. And, you know, a solenoid for sure is going to have a lot of energy going through it. 12 volts. But it should just be a set of windings. And, you know, it's like I don't see a particularly obvious failure. And there would have been no motion involved or like somebody cutting it. It literally was just on the car and I had used it and I went to hit it the next time and it didn't work. Interesting is the bobbin here doesn't actually feel like a designed bobbin. It actually feels just like a wire spool. It's kind of strange. Like you just bought like a roll of hookup wire somewhere. I mean, this is clearly old and it's been through a bit. It really looks and feels a lot like electrical tape. Not like a core laminate tape. Look at that. It's just that looks plain old magnet wire to me. I bet I can rebuild this. Have a perfectly functional solenoid. I bet that they choose to keep weight down and overall dimensions, but they want a lot of turns to get the force required. You know, they want a lot of actuation and the travel, but they probably, in designing it, just order a off-the-shelf assembly here. But weight and everything is one of those. So they may very well be making a choice, design choice, to say it will overheat if used somewhat continuously, but they do that because it would have to be a lot larger if they actually put in the right amount of windings for continuous duty. That's a reasonable choice. Normally pulling tape off of things is not that hard, but I mentioned this gets exposed to transmission fluid, which is a lubricant. So this is actually entirely coated in, first of all, what appears to be very burned, or not burned, but very worn and aged tape. God, I wish they had used something like Kapton. Also, actually, they didn't do any. It's enameled wire. They just put this on there to hold it. That's weird. Why would you do that? But anyway, it actually is kind of tricky to pull this off because it's got goo all over it. I see a fabric down there. In there. It's always nice to have extra parts for the car. You know, race cars are kind of one of those things that every time you take it out, almost something breaks. And that can ruin your day if you spend all the time going out to the track, get it actually unloaded, and then find out it won't run. I had that happen a few times already. Okay, well, I just nicked that enamel. I know this thing doesn't work anyway. Such the wrong tape. Somebody bought this and like wound it all. It just didn't spec the right thing. I mean, I'm sure they thought it's okay because it's just to hold the winding ends. They used enamel wire, but yeah, I think what happened is actually that the you know, enamel wire doesn't usually fail. From what I've seen, I'm sure people who have a lot more experience with transformers and big coils will correct me. But I mean, it looks almost like what happened here is it heated up and the electrical tape melted. And I wonder if it actually got hot enough that it ate the enamel off the wire. It's really strange. I mean, that's all like got this weird melty pattern on it, but there's nothing here. Like there's no, I don't see any obvious nicks or anything. did a really terrible job on this too. It's not even turns. Yeah. Actually, there's a couple places here where the enamel, you can see straight through it. I suspect. Yeah. Okay. So we overheated and the enamel failed. God, that seems like such a trivial thing to fix. Why would you continue to build these this way? If that's the failure mode. Yeah, now I can see some of the failure. So it got really hot and then it melted and you can see the enamel just burned right off. So it's the wrong gauge wire. Huh. I have to think about how to control that. I'll have to go read up on this, but on coil design. But if this is all that's in here, yeah, there's that whole center section just melted one chunk at a time. Huh. Really weird. Down here it's perfectly fine, it's just that center section. And they really did just turn a whole crap load on here. Like, they didn't even run it up to the end. Yeah. Actually, even the bobbin internally, you can kind of see it in there. It actually melted a little bit. But I'm sure I can get a new bobbin. Nothing in the metal failed. So, anybody who's from the automotive side and not familiar with electronics, I have no idea why this costs 120 bucks. That was me buying it from like Fuji Motorsports, but from what I can tell, I would have to look up the going rate on magnet wire or like enameled wire, and I will do that. Because I'm tempted to just rebuild this. But like, this, maybe 25 feet or something. Maybe 50 feet of wire here. And I don't even think this is, like I said, I think this may very well have been that someone literally bought a core. I'm gonna search. There's a part number on the top of this thing. Now I'm curious as to what it's really designed for. Yep. Yeah, there's a lot of enamel got melted off. God. But enamel wire is not expensive, and as you can see, this is literally just turn after turn. It's coil winding. People do this all the time for guitar amps. And I don't understand. Yeah. Got hot enough it melted. Melted the spool. Well now, I don't need to keep this. If you wanna, I'm sure, 100% sure that I can look up how to calculate the number of turns required for a solenoid. Do it that way. And that's all it is. It's literally steel housing, a couple of machine parts, and a giant coil of wire. I gotta go clean up. Okay, now that we've got the bench cleaned up a bit and all the fluid wiped off, a little bit about how this actually works. So, as we mentioned, this pin is in the middle, and it's going to strike out. And so, how and why did this fail? So, the spool actually, this fits inside the spool, and you can see that there's a space in there. And this other piece should fit inside, and it has room to move inside the case. If I look, it will sit against that base plate, and it should have a little bit of space to move back and forth. So naturally it'll fall, back. But what's happened in this case, the reason it won't go anywhere, that heated up and it melted the spool, and so this can't actually go in, and it can't strike the surface in there anymore. It probably was actually mounted that way, but that would let it fit inside the chassis, or inside the housing, but there's no way for it to go because it just overheated. So I got wondering, why would that have happened? I can't find anything about this particular part number, but I went and did a little research after I cleaned up, and so if you're building your coil, it comes back to fundamental circuit analysis. So it's a spool of wire, and so wire has a resistance per foot, and you're building layers of wire. So the wire gets stacked, and so the diameter of the wire, so the wire gauge translates to a diameter, tells you how many turns you can put per layer. And then also it tells you the height, which is also an amount of how many layers you can put on before you've filled the entire spool. And I went and ran that with a couple of different wire gauges. And so if I was going to start with, a 14 gauge wire, it would allow, when you calculate all that as to how long the wire actually would be, I forget what it was. It was, like 30-something feet of wire, but the resistance of that is also really low, which means it would allow about 100 amps of current at 12 volts, which would get super hot and would certainly melt things. So as you decrease the wire gauge, the resistance per foot goes up, and you also get to put more wire on. So the smaller you go, the more turns you can pack on, as well as the lower the current through it, which means overall less heat. So it looks like what would actually need to happen to be a safe margin is either to be really, really safe would be 20 gauge, and that gets you about 5.5 amps, which is within tolerance of what the wire itself the insulation should take in terms of heat. That also ends up being like almost 250 feet of wire. It's like 230 feet of wire. So it's a lot of wire, and that's not what was on here, obviously, because while there was a lot of wire here, that did not seem like 200 feet of wire. But as you change the sizes, and I was looking at, like, say, an 18 gauge, then it'd be significantly shorter. The current's higher, though, so it's about 13. So I'm guessing they probably put an 18 gauge wire on here. And I didn't work out I don't remember what the length was, but that would explain why it was kind of close to the margin of where the enamel would be expected to start to melt. So the easiest thing to do, actually, for repairing this is for me to actually like model this and make them out of something like ABS or something. I mean, ideally it would be something high temp, but you can buy 200C polyamide wire, so it's not enamel, it's magnet wire, but it's high temperature rated, and you can get that in 20 gauge. And quick look, 20 gauge, 250 foot is a 1 pound spool of wire, which looks to be about $20. So yeah, if you have a solenoid that burns out like this, they're like $20 to fix. The hardest part actually is if your spool melted, then you probably need a way to get a new one. So, alright, on to the next thing on the bench. But that's interesting, I can actually repair this. Nice to have a backup. What else do we have on my bench? Yes, this would be good to get out of the way. I don't expect it to be that interesting. So, we bought a '66 Mustang a while back, and you've probably seen the engine teardown that's happening. The previous owner, or one of the previous owners, had installed the alarm slash, I don't even know what all is in here. So it comes with a key fob. It has this little box that was wired in to the ignition switch and a couple other things. It had a whole bunch of inline fuses, or at least a couple. They used an inline relay. Which these are convenient. I actually really like these automotive relays. I don't know what Magic car brand is, but yeah, I use these. I don't like this holder. I have Littell Fuse makes a really nice adapter or a modular system for these, but I do like the form factor of the relays for cars, at least. So on this, it's just labeled CM1300. Don't really know much about it. Wiring instructions are on here. No company name anywhere. That's interesting. I'm kind of curious as to what the FCC ID turns up. And so, it has a lot of different options. So you can do 12 volt constant. The minimum is sort of your 12 volt constant, 12 volt ignition. It has an output for a siren. It also has trigger wires for doors and parking lights, so it knows when various things are happening in the car. It has a trunk release output, so that when you actually hit the trunk release button, it does that. It has driver's priority unlock output, so that would be to unlock the driver door only. Then there's a unlock and lock outputs. Horn, various things that you can hook in. And then this one down here, it also has an input for a shock sensor, so that's how you get the, did somebody actually hit the device. And then you have an LED that you can mount somewhere on in this case they poorly mounted it in one of the screw holes for the instrument cluster. So I don't need that anymore. And I'm not actually going to keep any of this of the wiring. I'm a little curious as to how the shock sensor works. Maybe we'll start there. So this is a CompuStar. Has an order number on it. Little dial for sensitivity. Otherwise, not obvious how you're supposed to open this. Spudger. There we go. Just snap. So, shock sensor. So even though it was labeled CompuStar, inside it's a Yongshin. Modest amount of circuitry there. Looks pretty simple. 2 elements suspended, probably measuring, let's just say JRC 2904, which if I remember right, those are just power or voltage regulators. And some transistors, a little bit of stuff here. My guess would be, without going into a lot of detail as to how it works, without researching it at least, it's clear that the gap inside of it is too big for, you would have to have a serious jolt for actual contact, but it's enough to develop a free air capacitor, would be my guess. And so when it hits something, it's going to cause oscillations, and it's also going to adjust that, and so then you can actually have your trigger threshold. Anyway, kind of what I expected. Don't really care exactly how it works. This one needs screwdriver. I can kind of understand why you might want to put a security system on a classic car, but I don't know why you would pick such a no-name, cheap thing. So, case is kind of nice. What do we have in here? That is a surprise, actually. So it looks like it has an 18 mega 168, and they're using a ULN 2003 as a driver. Looks like they have resistors on all the input lines for pull-ups and pull-downs. A couple of relays off the power inlet. I think that's the power inlet. Should have paid attention. Yeah, so that's the actual power inlet and trigger outputs. Yeah, the 12 volts, a siren, and also parking lights. And everything else is basically just current limited control through probably. There's a whole bunch of transistors, so they probably just have, switch 12 volts off the line there. But like right here, it's actually, they have the full breakout of ground, reset, meso, mosey. It's the whole ISP circuit header right there. I'm quite surprised by that, actually. And then over here, it's got a little RF front end. Has a 2904 that's capacitively coupled in. What are they doing? Yeah, there's a capacitor in there. And it's not clear to me what that's for. It must be voltage regulator. But they did some sort of discrete RF receiver. So it's probably some simplistic like on-off keying or something. Clearly not any sort of coded. Well, I mean, if it's this, it's probably, it could be FM, but they're going to be just transmitting like some simplistic code that you can actually recover off of the Atmel. Yeah, it's actually kind of convenient if if all these inputs and things are truly wired up directly to the Atmel. That makes for a really interesting development platform because any sort of 12 volt input, 12 volt output. This might require a little bit more investigation, keeping that around. Yeah, that's actually really interesting. I think I have some project ideas for that. I was completely expecting a like single chip, super optimized, one chip does everything kind of solution, but it's not. So maybe I do want to keep some of these connectors, cables. Not that I have any interest in, a shock sensor, but I do know that, in the race car, for example, they have steering wheel controls. In that case, it's for like cruise control. Didn't have steering wheel controls for the stereo or anything. But I don't have a cruise control system in a race car. But it would be cool to use those buttons, and I was going to have to build a system that can take measure the resistance across those, because it's a resistance-based system. Often those buttons are actually two wires, and they each of the buttons turns on a various resistor, so you can actually figure out what it is by measuring all the resistance. So, yeah, interesting things. So we'll keep those cables. We'll keep that cable too. Alright, well that was strange and fascinating. And we'll keep the remote here. Yeah, the cool part is with that being a 18 mega 168 is, even though it doesn't have the serial interface like you would in Arduino, it's still the same chip. So you can use the Arduino software to write and then use a normal AVR ISP to program it. So. I really need a second sputter that's a little stiffer. So, wow, this is also not what I would have expected. So usually these are coin cells, but in this case it's actually one of the 12 volt A23 batteries. And yeah, it has Magicar Yongshin, 4 buttons, and what's on the back? Not a whole lot. 2 chips, Rato RT1527, and a DR01. Oh, that's labeled SAW1, so that's a SAW filter. And I don't know what that is. I mean, it's hooked to the switches, obviously. And it does feed into the RF circuitry. So this very well might be the super optimized solution. 2005 date on here. So, yeah, I'm going to have to think about that, because if I have a remote and that remote also works or talks to an Arduino, or at least an Atmel similar to an Arduino, and it has a bunch of 12 volt inputs and outputs, that's really fascinating. Yeah. Antenna module TXRX, but I have an actual antenna here. Fascinating. Yeah, I can imagine actually using that with the race car. Not for starting it or unlocking doors or anything. I mean, it has a key fob for that, but I can imagine it being a way to communicate with my driver, because in the drag race car, I don't drive. I actually tune the car and do a lot of work on the side, but I could see that being, you know, I hit the button to give a go signal after looking at all of the parameters. Yeah, I have to think about that one. Alright. Well, that goes in there to play with more. Let's take this one. It's been on here for a while. This requires a little bit more explanation. So I have a couple of older vehicles. I have two 1966 Fords. I have a Mustang and a Econoline. And both of them originally would have been carbureted. They would have been, and they were inline 6-cylinder engines with traditional points ignition systems. And the way a point system works is, you know what, I'm going to wait. I'm going to pull all this stuff out and show how points works to do that. And then we'll take apart how that actually works. Well, I might be done for the day then. I think, actually, I'm going to tear open this. So I have a Nexus 5 that just completely and utterly died on me. And I don't care about it. I already replaced it. And I had taken this apart once to replace a bad USB connector. And it probably was just a bad battery connector this time, but... Or a bad battery, not necessarily a connector. Oh... I know you come off, because I've done it before. Oh, actually, no. That was a 5. That was a Nexus 5, not the 5X. I never had this one apart. I'm sure that other people have done teardowns. And I don't care that much about what's inside. It's somewhat interesting to see, but... Okay, so as expected, internally it's pretty much a giant battery. That's pretty darn normal. They often have the contacts to antennas that are actually stickers on there. Camera module. That probably pops out actually. I remember having a discussion with one of the guys that worked on Street View cars early on in my career at Google, and him telling that the early Street View cars actually did just use cell phone cameras because the cameras were really cheap, and actually the image sensors are really good. The challenge was making optics that were good as well to fit them. So the big soccer ball Street View cars were actually a whole bunch of camera image sensors with about $200 per camera of optics. And that's what they used for many, many years. They've since revised that. I mean, I think they still do use the same types of cameras, but... Oh, I completely destroyed that. I assumed it just popped off, but it doesn't. That's actually just the lens module. You can actually see the CMOS sensor now. Yeah. Getting underneath this and getting down to the actual motherboard. Oh, God. They always glue these battery packs down. It's like the things you shouldn't be doing. Prying on a battery, a lithium polymer package. Why? Because they can rupture when you actually are prying on them and bending them. But then they actually glue it into place. They have no interest in anyone repairing these things. Which, you know, I understand that's part of their market value and whatever. I don't care. Oh, God. I even have special screwdrivers for this. All I want to do is kind of get a look at what the latest and state of the art is. My puppy making long yawning sounds. After I finish taking this apart, we'll go take him for a walk. Yeah, I have repaired a couple of phones, but it gets more and more like, you know, I've already, in order to pry off the main case, I damaged the material, so it's very obvious that it was broken. And if you're going to replace the battery, for example, we've already established that that would be a pain. And then you get inside and it's like, here's the battery connector. So you have to strip it all the way down to that point to actually get there. And then the rest of this is pretty much one board. So you're not going to really repair things anymore. It is possible. I mean, you can swap out a new battery, and in this case there was a known thing with the 5 and 5X that the power buttons would fail, or at least the 5, that was a really common problem. And I know 5X people have just noticed that it seems to die overall. So, yeah, some interesting things. There is the front-facing camera that I could take out, but it's pretty crappy quality, and I don't really want to mess with it too much. And these are all shielded, which is good, but it means that I would have to spend time desoldering all of them to get any visibility under them to see the main processor or anything. Oh, maybe not. Maybe will it just pop off? Ah, it will. See, this is what you can do when you just don't care. Yeah. So it is a Qualcomm. I mean, I knew that, but I had never actually pulled one apart to see how small it is. That's PM8994. That may not actually be the main processor. That may be the power management chip. It's usually a significant part of the design is actually the power manager, the actual RF baseband, and then the main application processor. Kind of the three main parts of these. Man, oh man. Yeah, it's like this is another flex to do. It's in the front speaker. It's amazing how they pack all this in here. It's like the flex has circuitry on it. Wow. Oh, right, because there's a light that actually flashes underneath there. The headphone jack actually is mating. So that board sat like that. So the headphone jack actually just has pads, or has connector pins there that are spring-loaded, and they actually did castellations inside the PCB edge. Very, very minor. And they did that so it's actually a pressure fit connection on the headphone there. Yeah, neat. Neat, that's a neat trick. I'll have to remember that. Yeah, see, that was the power management. So now we've got Samsung, another Qualcomm part, I'm going to guess that the Samsung is actually the RAM. I've already taken the SIM out. Oh, probably a RAM. Probably flash. Yeah. Anyway. I think these would be soldered down. Those two are. There's got to be a radio baseband in here. Anyway. Yeah, so there's still more things to tear down. I think some of these, like I said, the ignition will need a little time to do. I also have this guy, which is a voltage regulator from my 66 Econoline. And it's the mechanical voltage regulator. So I actually want to spend some time working out how that all works and kind of illustrate the principles on that and the circuit design that goes around it. I have the wiring diagrams from the official service manual. And yeah, there's some other odds and ends, but they're going to take a little time to actually put together. Well, yeah. That's all for today.